Hello, now we are going to look at angles and triangles in some detail. So if we think just about the angles in any triangle, they must all add up to 180 degrees. We'll look briefly at why in a minute, but the angles in any triangle in a three-sided shape with straight sides must add up to 180 degrees, regardless of the shape of the triangle. Another rule that we have for angles and a triangle is for isosceles triangles. The angles opposite equal sides are equal. So our lines here mean that these two sides are of equal length, and the angles opposite those equal sides, angle 1 and angle 2 as I've labeled them, must be equal to each other. That's true again for any isosceles triangle. The angles opposite the equal sides must be equal to each other. For an equilateral triangle, so equi means equal and lateral means side or length, so an equilateral triangle has equal side lengths, and a result of that, a consequence of what we just looked at, well, if we have the angles opposite equal sides are equal to each other, that means that this angle must be the same as this angle must be the same as this angle. So an angle plus an angle plus an angle must add up to 180 degrees. So each of the angles must be 60 degrees, because 60 plus 60 plus 60 adds up to 180. So the rule for an equilateral triangle is a consequence of what we looked at for our isosceles triangles. The other type of triangle we often deal with is right angle triangles, and the tools that we know connected to that. So a right angle triangle has our capital L looking symbol, or it could also be turned the other way around and you could have a box looking thing in the right angle corner. The tools we know for dealing with right angle triangles, the particularly important ones are Pythagoras. So the hypotenuse squared, the side across from the right angle squared, is equal to the other two sides squared and added together. And we also know that the area would be half the base by the height. As I've labeled it here, we have a base and then the perpendicular height from that. So the perpendicular distance from our side A up to the far corner of the triangle would be B. So those are our rules for that. And another method that we have for the angles in a triangle is the exterior angle. So the exterior, which means the outside, so the outside angle to the triangle here would be the angle C. The exterior angle is the sum of the interior opposite angles. So if we look at this picture, we have a lot of language going on there, but the angle A plus the angle B must end up adding up to the angle C. And this comes from the fact that we know that C plus this angle next to it would be 180 degrees, and A plus B plus this angle must add up to 180 degrees. As a consequence, A plus B must be equal to C. That's where the rule comes from. So this can be useful for solving some problems that would be a little bit irritating to have to do more step by step. Now, if we have two parallel lines going here and we have our triangle drawn in between them, how would we find the value of x? Well, we're going to have to use what we already know about angles and lines and combine it with what we now know about angles and triangles. So what we do in these types of situations is fill in all of the information that we can figure out based on what's given to us. I can see that these three sides of my triangle are equal to each other. So I'm dealing with an equilateral triangle here because all three sides are equal. Well, in an equilateral triangle, I know that all of these angles, all three angles, must be 60 degrees because all the angles have to be equal and they have to add up to 180 degrees. Well, from there, I can immediately say that x must be 60 degrees because this is an alternate angle. I have parallel lines and I have a straight line crossing my parallel lines. So the angles that alternate on the sides of my line are equal. So I can write that down. And whenever we write down, whenever we use a rule like that, we always write it down to reinforce that tool in our minds. Why is x equal to 60? Because they're angles that alternate on a line when we're crossing parallel lines. And the more we reinforce that understanding by writing down the name of the argument, the better off we are in the long run. Now, this is actually leads pretty easily to the reason why the angles in a triangle add up to 180. So very quickly, you now know that at x is 60. So you know that that angle there is 60. Likewise, using the alternate angles, you know that this angle up here must be 60. So you can see that the angles down here in the triangle must be the same as the angles up here. Now, that's true for any triangle. We can draw a line parallel to the base of any triangle and end up doing this, that we have our alternate angles must be equal here and here. And we know that this angle, which was originally labeled x plus this angle forms a straight line, which has 180 degrees in it. So that means that these three angles must sum to 180 degrees, and these two angles are equal to these two angles. So therefore the angles in a triangle must always sum to 180 degrees. That's where this first rule is coming from. If there are 180 degrees in a straight line, then there must be 180 degrees in a triangle. So that is what we have. That is a brief discussion as to why we have 180 degrees in a triangle. Now, let's see if we can find angle A and angle B. As before, we fill in any information that we can see in the question given to us. So what jumps out at me here is I have an isosceles triangle because I have equal sides in this triangle here. So that means the angles opposite the equal sides must be equal. So the angle opposite here must be 70 degrees. These two angles must be equal to each other. Well, I now know that the angles in a triangle add up to 180 degrees. So I can say 70 plus B is 180 degrees. So I can find the value of B. I could also find the value of A because I can see that this is on a straight line. So 70 plus A is 180 degrees. And we have a third option as well. So I'm going to find B first, and then we're going to find A. But do these questions multiple ways in order to reinforce our understanding, to reinforce our thinking. So now I've found that B is 40 degrees. The method I'm going to mention is for finding A, you could use the exterior angle because A is essentially the exterior angle as we've set it up. So B plus 70 must add up to A. So 40 plus 70 must add up to A. Or we could say, as I said before, 70 plus A forms a straight line, so that means that it must add up to 180 degrees, and rearranging we get that A is 110. So look at these questions from multiple angles, from multiple perspectives, so that we train ourselves to be able to spot all of the patterns we need to be able to see. Now, how do we find X and Y? Well, as always, fill in anything that you can see in the question. So here I have 2 dashes here and 2 dashes here on this little triangle. That means that this angle X must be the same as this angle X over here. So I have that angle there must be X. Is there anything else I can fill in? Well, I would be able to figure out what this angle is in here because I know there's a straight line going across here. So 60 plus this angle must add up to 180. Or I could say that I can see I have the exterior angle here, so I have X plus X must add up to 60. So I have two ways of approaching that. So I can find that X, my two X angles here, must be 30 degrees. Now it's worth noting I can't see immediately how to get Y. X wasn't too bad. I could see I could fill in this triangle and I'd have 120 plus X would be 180, or I could do the exterior angle that I've already written up. But I can't immediately see how to get the angles I need for Y because I don't know how to get this angle. But now that I've gotten X, I can see that I could find this angle by adding 70 and x, and then the remaining angle in the 180 would give me this angle in here. Now I've worked out what z is, I now have the other two angles in this triangle. Also, I am able to say 60 plus z plus y is equal to 180, or I could say 120 is equal to y plus z. And I work out that y must be 40 degrees. Now, how would I find alpha and theta? Well, again, fill in all the information that we can immediately see. I have an isosceles triangle going on here, so I know that this opposite angle opposite at the equal sides, must also be alpha. So I know alpha plus this angle must add up to 180. I can also see that alpha plus alpha must add up to the exterior opposite angle, which would be 110. Or I could find theta by saying that at 110 plus theta must add up to 180. So there are lots of different ways of approaching it, and it's important to write these questions out in multiple ways. Now, if we found theta first, if we got our 110 plus theta added up to 180 from the fact that it's a straight line, and got theta is 70, well, how would we find alpha going in that direction? Well, we would be able to say that theta is vertically opposite to this angle inside the triangle. So we'd be able to say that that angle there must be 70 degrees. So we'd be able to say 70 plus alpha would be 180. So let's write that out that way as well. Let's take that different perspective. And we see that again using that argument, and we end up with alpha is 55 degrees as we found via using the exterior angle. So the more we are able to look at these questions from multiple perspectives, the better training we get, and particularly importantly, that we are always writing down why our argument is true, that we're using the fact that we've got the exterior angle, the exterior opposite angle of, the exterior angle is equal to the sum of the opposite interior angles, or the fact that what we're doing is adding up to a straight line, or the fact that we have alternate angles, and that we're always writing down why what we're doing works is very important, because there are a lot of tools in geometry, and we need to be reinforcing for ourselves all of the time what they are and why they work, so that we can use them creatively in an exam setting. And that's what we need for now.